Okay, Bismillah ar-Rahman ar-Rahim. This is your teacher speaking, Ahmed Musameh, and we are still with ELET104 computer programming. Now, inshallah, today we will discuss the module 5. Module 5, the topic is arrays. First of all, we have to know the definition of array. As you can see on the screen, an array is a data structure which contains multiple data items of the same type. Of course, this definition goes for the single and the two-dimension arrays. So it's very important that you know the definition of arrays. That means that the array is a group of characters, many data items. They have to be of the same data type. That means if you create the array to be an integer, all the data in this array has to be integer. Float, all the data in this array has to be float. Okay, so as we can see here, data type, the array name, and the size. For example, the data type, we know the data type is 4, integer, float, char, and double. The array name, you can choose any valid name for this array name. The size, we have to write the size in square brackets, and the semicolon at the end of the creation of the array. For example, if you look at this example here, the array name is X. We created 10 elements. And of course, the computer starts counting from 0. So this element, we call it X sub 0. This is called index. The 0, we call it index or subscript. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is very important that you remember that the counting starts from 0. Okay, now let's look at this example here. Example 5.2, this is the array processing. We have two arrays here, A and B, and we have some numbers already stored in this array 5, in the array A5 and the array B, and we can do some mathematical processing on these two arrays. If we say here A sub 1 plus B sub 1, this is A sub 0, this is A sub 1, which is 10, B sub 0, B sub 1. So this is B, A sub 1 plus B sub 1. 10 plus 3 is equal to 13. A sub 0, which is 12, minus B sub 0, which is minus 5. This gives us 17. And of course, we can do the relational operators, and we can also work on the logical operators on this example. This is very important that you understand this example for your assessments, quizzes, and final exams. Okay, part 1. Let's look at the single dimension array. How do we declare a single dimension array in C language? First of all, we have to mention the data type, then the array name, and then the size. For example, the data type, we can select any one of these 4, integer, float, char, or double. The array name is any valid name you choose. Then the size, we have to write it in square brackets, and we have to end the declaration of the new array with a semicolon. Define, declare a one-dimensional array, 60 elements, integer type, integer array called TR. So how do we create this in C language? We say integer TR, the name of the array, square bracket, 60. We close the square bracket and the semicolon. Okay, now we come to how to input scanf data into a single array. Of course, this is using the keyboard. It says here, write a C statement to input data into a single array using keyboard. Suppose we have this include stdio.h, void main, integer x sub 3 elements, and I. We have to This will create an array called X, and it has 3 elements. And this I here, this is a variable. We have to use I in order to move from one element to the other element. So this is the creation in the computer memory, X55. So the creation in the memory X, and it will create 3 elements. And as we said, the first number is stored in X sub 0. The I here will take care of this 0 here, the index number. So in order to do the input, we write for loop, we have to use the for loop. For I equals 0, why do we start from 0? Because the first element is stored in 0. Semicolon, I less than 3. This has to go 3 times. Plus I, plus I. This will give us the chance to move from one element to another element. Scanf person the ampersand x sub I. So here, if this is true, it will come down here. Scanf ampersand x sub I. The first value of I is 0. So it's the first number you write, 55. It will be stored in the x sub 0. And when we go back to the for loop, we go to the end of the for loop, plus I. This means I equal I plus 1. 0 plus 1 is 1. We check the condition. If this is true, the scanf, the second number, which the user input, it has to go ampersand x sub 1. Then we go to the end of the loop, plus I. 1 plus 1 is equal to 2. 2 less than 3, true. We go to the scanf. Now the third number, it will be stored in x sub 2. Now we come back to the for loop, plus I. 2 plus 1 is equal to 3. Now we check the condition. I is less than 3. No, I is equal to 3, which is false. That means we have to exit outside the for loop. Okay. So now this is the input. The output is the same. Just copy, paste. Instead of scanf, we have to write printf, and we have to remove the ampersand for the printf. This is very easy, very simple to do. And also we have two examples. We have two examples given in the information sheet, example 5.3 and example 5.4. For example 5.3, we have to enter data into an array of 5 elements, and then we have to select a certain element to see what is the number stored in that array. Okay. Example 5.4, this example, we have to enter. This example calculates the average of 5 student marks. So we have to create an array called marks of 5 elements. Then we have to issue a float. We have to use the I float sum is equal to 0 and the average. For I equals 0, I less than 5 plus I. This will give us the scanf to input numbers into this array. After we finish, we have to calculate the average, which equals the sum divided by 5. Each time you enter a number, we add the new number with the old number. Okay. Sometimes you can see this example, integer x of 5. We have 5 elements in this array x, and this given in the braces 9, 20, 33, 45, and 8. Okay, that means you are creating an array named x of 5 elements, and you already stored these numbers in this array. So if we say here x sub 0, this is equal to 9, x sub 3 equals to 0, 1, 2, 3. So this is equal to 45. So this concludes the the single dimension array. Now we come to the two-dimension array. Two-dimension array. How do we declare a two-dimension array? We can say integer, this is the data type, x is the name of the array, square bracket 3, square bracket 3. The first number is for the number of rows. The second number is for the number of columns. So if you can say here, just like creating a table in Word. So this is a table of three rows. This is called row, and this is called column. Okay, so this is 3 by 3. First number 3, this is given to the number of rows, and the second 3 is for the number of columns. Okay, and the first row is row 0, row 1, row 2. This is column 0, this is column 1, and this is column 2. The first cell here, we call it R0, C0, yani R0, column 0. This is R1, column 0. This is R2, column 0, column 0. This is R0 column 1. This is R1 column 1. This is R2 column 1. And this is R0 column 3. This is R1 column 3. This is R2 column 3. Okay, so this is the example here, as you can see on the screen. So this is row 0, this is row 1, and this is row 2. As we said earlier, that we have to start from 0. To declare a two-dimensional arrays in C language, for example, declare two-dimensional array called table. This is the name of the array that is 50 by 50 elements floating point. That means we have to create a table of 50 rows and 50 columns. The name of the array is called table, and the data type is float. Let's see how we input information, how we input numbers into the two-dimensional array. When we say input, that means we are using scanf. When we say output, that means we are using what? Printf. For example, include stdio.h void main integer a, this is the name of the array, 3 by 3. That means we have 3 rows and 3 columns, and we have to use 2 variables, 2 new variables. One is called I, and the other one is called j. The first variable I, this will take care of the rows. The second variable j, this will take care of the columns. These 2 variables, you need them in order to move from one element to the other element inside the table. Then we come to the for loop, the scanf, or in order to input data into the second two-dimension array, we use for I equals 0, I less than 3, plus I. This for loop will take care of the rows. The second for loop for j equals 0, j less than 3 plus j. The second for loop, this will take care of the column. Then we issue the scanf %d ampersand, capital A. A is the name of the array, and then we write I and j. I and j. Okay. So this will take care of the how to input data into the two-dimension array. Okay, after you enter the data, you like to display the information you stored in the two-dimension array. The same, we have to use the same for I, for j, and the scanf copy. We copy the first 2 loops, 4 loops. Same, there is no changes. The scanf, we have to copy it and paste it here. We have to change. Instead of scanf, we write printf, and we have to remove the ampersand, which means they are very much similar to each other. The input and the output. But for the output, we have to change. Instead of scanf, we have to use printf, %d, and we have to use the ampersand, this one, and we have to remove it for the printf. And this will allow us, this will show us the data which you entered in the two-dimension array. Okay, and this is another example here, how to enter information into two-dimensional arrays. Include void main, integer a, 3 or 4. This is 3 is the number of rows, 4 is the number of columns. I and j, the I is we use it for the rows, and the j we will use it for the columns. For I equals 0, I less than 3, plus I. 3 is the number of rows. For j equals 0, 0 because we start from column 0. Column 0, j less than 4, this is the number of columns. Okay, plus j, and then we say scanf %d ampersand a, I sub, and j. This will take care of the input. The output, the same. Copy, paste, but instead of scanf, we will change it to printf, and we have to remove the ampersand. Okay, there is another example, is how to do an addition of 2 arrays. Addition of 2 arrays. Include stdio.h void main integer a, 3 by 3, b, this is a two-dimensional array called a, and this is two-dimension array called B, 3 by 3 also, and this is the output array. So A and B are input, C is the output. And we have to use I and J in order to take care of the rows and the columns, give you the freedom to move inside the table. Then, as we saw in the earlier, the examples, in order to input, we have to use two for loops, one for I and one for J. This will take care of the rows, and this one will take care of the columns. And we issue the scanf. And then this is for the array A. This one, the same, copy paste. We just change the name of the array to capital B. This will take care to enter the information, the data into array B. And then we say for loop for I and for J, C I sub j equal A and B. This here, it will add the array A plus the array B, the output. We will store it in the array which is called C. Okay, to show to display the information or the output of the addition of these two arrays, we have to issue for I, for J, and then printf. This will show you whatever you entered in the array A entered into array B. We do the addition, and then we have to display the output on the screen. And this is the questions: define, declare, define. This is how to use this program in order to display the output of this program. And here we have to write a program to display the maximum of elements in a single dimension, entering 10 numbers, which is the maximum number in this 10 numbers. And this program, write a program 3 by 3, two-dimensional arrays, compute and display the sum and average of its elements. Okay, this is similar to the example 5.4. Okay, I hope, inshallah, you understand the module 5. Thank you.